Java lesson. In this lesson, we will discuss about the core concept of static keyword. A static keyword is mainly used for memory management. A single copy of a static data can be shared by all instances of a class. As for example, the school name for all the students of a school is common, so can be kept static. Static keyword can be applied to a variable, a method, a block, or a class inside a class, or nested class. Nested class will be discussed separately in next coming video. Static variables are also called class variables. It is available on class level and can be accessed by the name of class. Static variables are shared among all the instances of a class and gives a way to keep a single copy of data for all the objects of a class. For example, company name for all the employees, school name for all the students of a school, pi for all the objects of a circle. It makes our program memory efficient. Let us see it by an example of a code.
Let us see the static variables effect by an example. Here is a code to create a class of circle with a radius and a pi as a data and a constructor to initialize those values. Now one main method to test this code. When I will create a circle object, there is a stack memory where the variable stores and a heap memory where object is created, and due to this is equal to operator, C1 refers the object into the memory. So C1 has its own copy of radius and pi. Similarly, if we will create one more object, C2 will be stored into stack, object will be there in heap memory, and C2 is referring this one, but once again the pi is having same value, but C1 is having its own pi and C2 is having its own pi. Thus the value of pi is repeated, and if we will create more object, each object will have its own pi value. However, we know that this pi is common for all the circle object. So it is a wastage of memory if we will create pi independent for each object. However, it is necessary because each circle must have its own radius. So let's see another program code with the help of a static keyword for the pi variable. Now the same class with pi as a static variable and a constructor for initializing radius. Now in this case, in main method, if we will code the circle class will be loaded into memory and the pi is there. Now C1 is in stack memory, the object is in heap memory, but object is holding its radius value only, and the pi is shared from class loader area to the C1. And similarly, if we will create one more object, a variable will be here in stack, the object will be in heap memory with its radius, but the same pi will be shared for this one also, and hence if we will create more object, each object will have its own radius, but the value of pi will be shared from class loader area, and in this way our program are more memory efficient and it saves the memory.
Let us make one more program to count the number of objects created.
So let us start by creating a class. Okay, just change the name by class rectangle to data member, then a constructor. Suppose these two has 10 and 20 as default values given through a no argument constructor, one more constructor with single parameter, and both are initialized with the same value, and two parameterized constructor. Now suppose there is three constructor to create object, and if I want to know how many object is created for this class, for testing I am adding one main method. And now, so in this case any one constructor can be used to create object, but how many objects are created, if we want to display this, then we can have a static variable as count and give it as initial value 0. So now if I am creating rectangle R1 is equal to new rectangle, then the count must be incremented and is count plus plus, and do the same incrementing values in all these constructors, so that if any one constructor is called, the value of count is incremented. And since count is a static variable, it is shared by all the objects, so when count will be increased, it will be a single copy available for all the objects. So anytime when we will try to display, so in this way I have created three different object of rectangle using three different constructor. On calling each constructor, the count is incremented. So if you want to display the value of count, I'm just displaying using system dot, and there is no need to use any instance variable like r1 dot count. It is not needed. Just use count and it will display the value. Let us check. I have to save this program, so I'm going to decolon, and here I'm keeping this file as abc.java. Using double inverted comma will safely save this file as a Java file instead of .txt file. Save, and now compile this program and execute. So this is why, because the class name is rectangle. So first time the value of count was 1, second time when the object one more object is created, this becomes 2, and the last time it becomes 3. So finally I got the value 3 from here. In this way the count is a single copy and is incremented on by each constructor, so we are having this value 3 as output.
Static methods are a class method which doesn't need an object. It can be directly called by the class name, and it can only access static members.
Let us see an example of static method here. Suppose I am adding a area method for rectangle class. It will display one more class I am creating here, in which I am adding a method of a static type with rectangle as a reference. And r.area. Now, since callMe is a static method, it can directly be called by caller. Now, adding one more class for main method. Create 3 instances. Now, suppose I want to use this callMe method to display area, then I can call caller.callMe. Without creating instance of caller class, I can call the method callMe. Okay, but if I want to say rectangle dot area, it is not correct, because area is a non-static method and it can only be called with the help of reference variable like r1 dot area. It's okay because area is a non-static method and it can only be called by reference variable r1, r2, r3. However, callMe is a static method and can directly be called by the name of its class, caller. And now I am passing the object here of rectangle type, and in this way the callMe is directly called by the class name, and passing this r1 will go here and it will display the area. Let us check this program by compiling and now run user, because user is the main method. User holds the main method here, and hence we have all the 3 area calculated for 3 different objects.
In the previous video in which I discussed about constructor, we know that non-static data members are initialized in constructor through anonymous block, but the static data members doesn't need to create object. They can directly be called by class name. So in such cases, static block is given by the Java compiler to initialize static variables. Let us see by an example.
I am removing all this code and making a new class with ABC and double type count equal to 0. Let us compile this code. Now, there is no constructor, so there will be added one default constructor on compilation and nothing else. So let us check it by Java P. So there is one double type of count variable and one default constructor. Now let us set that variable double as static and let us see what happens. Save and then compile, and now Java P. What's happened? It's a static block. One static block is added here. Actually, this has happened. Why? Because the static data member is initialized in a static variable, and internally it looks like this. Looks like this. So a static block is just a block which initializes the static variables. I am using higher version, but if you use 1.6 Java 1.6, then you can directly call without having any main method. You can run your program like system.out.println hello world, and then system.exit 0, and this program will execute if you are using the older version. In this version it says that main method is not found, but in earlier version you will see that it is directly executed, because the static block is the block which is executed first of all when the class is loaded into memory. So let me show you, just adding a main method to satisfy itself rule, and there is nothing inside the main method. Just to fulfill the rule I am adding this one method, and now let us check what will happen in Java ABC hello world. However, there is nothing written in main method, because when the class loaded into memory, this static block is started to execute and it says hello world, and then system.exit closes my application. So I have written nothing in main method, even my program is running. So if I wish, I can add code into static block. So here I want to say just one thing, that static block is executed when class loaded into the memory. It's most important thing to understand. So when the static block is loaded into memory, if there is any static data like count is equal to some value, it will also be loaded into memory. Class is loaded into memory, the count variable exists, and so we can directly say system.out.println and then count without having any reference variable. The value is 0.